Hey guys, welcome to today's session. Today we're gonna talk about how to find a sample size using the maximum margin of error. Okay, and before we do anything, please pull up your slides from Google Classroom, and we will get started. We are currently on slide 19. To determine the sample size, N that will yield a C% confidence interval. This C% is your confidence level. For a population proportion P with a maximum margin of error ME. ME is the maximum margin of error they will give you in the question. Solve the following inequality for N. You need to solve for the inequality for N and see to determine what is your sample size, where P is the guessed value from the sample proportion. P is the guessed value for the sample proportion. And they will also give you in the question. The margin of error will always be less or equals to margin of error if you use your guessed sample proportion as your 0.5. Okay, let's look at the example. So read this example and find the information you need from the question. All right, so you can pause the video and read the question very quick, or we can read it together. A company have received complaints about its customer service. The manager intends to hire a new consultant to carry out a survey for customers. Before contacting the consultant, the company president wants some ideas of the sample size that she will be required to pay for. One value of interest is proportion P of customers who are satisfied with the company's customer service. She decided that she wants to estimate to be within 3% points at a 95 confidence level. How large the sample size is needed. So in this question, okay, let me put myself on. All right, in this question, like we can imagine when you do a satisfied survey, half of the people will be satisfied, half of them will be not. So the guessed proportion of the customers who are satisfied with the customer service, we can imagine that will be 0.5. So over here, our P is 0.5. Half of the customers are satisfied, half of them are not. Okay, and then Z we get from the confidence level. So the confidence level in the question is 95%. Okay, so which means our area we want to find is 95%. Which means each side will be 2.5%. Okay, and 2.5% is 0.025. Use your Z table, you get the value of Z star is 1.96. If you do not familiar with this procedure, you need to go back to my last video, 4-step how to find the 4-step procedure. There will be more detail on there. Okay, so Z 1.96. And then over here, we don't know N, we want to solve for N, so leave it that there. And what is your ME? In the question, they said they want it to within the 3% points, which is 0.03. So ME is 3%, which is 0.03. Okay. All right. So over here we have everything we need. We just need to solve for the inequality. So plug everything into the inequality. 1.96 times probability 0.5. Proportion 0.5 times 1 minus 0.5 multiplied by N, okay, and less or equals to ME, margin of 0. All right, so for this one, I will solve it step by step for you, but for the next question, I probably will not go into that much detail. Okay, so how to solve that? First of all, you're gonna divide it by 1.96 each side. Okay, on the left side, 1.96 cancel out, so you have 0.5, 1 minus 0.5, divided by n less or equal to 0.03 divided by 1.96. Over here, be careful. I just use a fraction. Do not actually divide it because it will be a very small number. If you only round it to 3 or 4 digits, there probably will be 0. So I will just write like this. Okay, that's it. And then the next step, we want to get rid of the square root. You need to square each side. So let me use a red pen. So square each side. Okay, over here you also square it. Then the left side, you do not have, you don't have anything. You just have everything from inside. Let me take this away. Okay, so you have 0.5 times 1 minus 0.5. This is a parenthesis. N. Again, I do not multiply it out because it will be a super small number. I just leave it like this, okay? And the next step I will do, I multiply n by each side to get rid of the n. Okay, multiply n by each side. Okay, and then over here the n is gone, and over here you have this, whatever this is, n equals to the left side. Alright, next step, but I want to solve for n. I need to get rid of this part. So I divide it by the whole thing on the left and right. So eventually you will have 0.5 times 1 minus 0.5 divided by 0.03 over 1.96 squared, less or equals to n. Okay, so you just need to plug this everything inside your calculator and make it make n greater than that. So I will do it on decimal for you, and so you will see what that looks like. On the calculator, it's the same thing. You have to like put everything in there. Okay, all right. Okay, let me pull up decimals calculator. And 0.5 times 1 minus 0.5 divided by 0.03 divided by 1.96. Okay, I have 1.67 dot 11. 1067.11. Okay, all right. Okay, so 1. So let me put it over here. 1067.11 have to be greater than or equals to that. Okay, so think about an integer that is greater than 1.67.11. The integer, this integer we want to find is 1.68. So this will be our answer. Okay, so if the company want to get their result within 3% of their guessing, which is 50%, they want to their result in between of 47 to 53, they need at least 1,068. I'm sorry, my dog is distracting me. 1,068 sample. Okay, all right, so I will erase the whole thing. We're gonna try another one. All right, so next question we're gonna try is example number 6. Example number 6 saying we are referring the same question. Instead of this time, they said, in the company previous survey, 80% of the customers surveyed said they were satisfied. So this time, instead of 50%, we are using 80% as our guess proportion. Use this value as a guess proportion. Find the sample size needed, a margin of error at most 3%. So ME does not change. And the confidence interval, confidence level does not change, 95%. So let's try this one. Okay, all right, let me pull the, all right, so we talk about, let me make this like closer to each other so you can see better. So over here, the P changed to 0.8. So guys, over here, our proportion get bigger. Let me record the result. So 1068 is my last number, okay? All right, and the Z-score and the Z does not change because the confidence level does not change. Confidence level still 95%, so Z star still 1.96, okay? Margin of error still 3%. Margin of error does not change, okay? All right. So now let's repeat the procedure and do this again. All right, when I'm doing it, please, you do it on your paper as well, okay? So plug in your values. 1.96 square root of 0.8, 1 minus 0.8 divided by the sample size, which we want to get, less or equal to 0.03. Okay, first step, divided by 1.96 on each side. So I have 0.8 times 1.0.8 divided by n is less or equal to 0.03 divided by 1.96. Again, this value will be super small, so we just leave as it is. Next step, square each side. You have 0.8 times 1.0.8, 1 minus 0.8. Okay. Divided by n is less or equals to, I will just keep everything here. And next step, we're gonna multiply n by each side. So n is over here, n over here cancel out. And then divided by this whole thing on the left. So n is greater or equals to 0.8, 1 minus 0.8, and 0.03, 1.96 squared. And put this whole thing in the calculator, and let me go to the calculator, edit a couple things. All right, so if you want to see my screen and see what I'm doing, here is what I'm doing. I changed the first number to 0.8, second number to 0.8, and nothing else changed. It's 682.95. All right. N is greater or equals to 682.95. Okay, so we want to find the first integer greater than that, so that will be 683. Okay, so over here we get a conclusion. When the proportion get larger, then your sample size will get less, get smaller. Okay, so over here, remember, if your your guess proportion get bigger, then your sample size required is getting lower. They don't need that much sample. Right? So this is the first question in example 6. Let's look at the second question. Second question say, what if the company president demands 99% confidence instead of 95%? So this time the confidence level change. Would this require a smaller or larger sample size? Assume everything else remain the same. All right. So over here they said the the confidence level become 99%. So over here I need to change my z value. Since the since the confidence level is 99%, so over here inside is 99%. Each side will be 0.05, 0.005, which is half of the 1%. Let me make it like look nicer. 0.005. So you're gonna find this value inside the z table, and then you got inside the z table for area. So then you got your z star as 2.57. Okay, and the margin of error does not change, 0.03, and the proportion we're using from the original question is 0.5. Okay, so right now the only thing changed is the confidence level get higher. Let's see what this sample size will change. So again, we're gonna plug in everything inside the inequality. 2.57, 0.5, 1 minus 0.5 divided by n less or equal to 0.03. We're gonna repeat the whole procedure again. If you don't not very familiar with inequality, please find some practice to do. Okay, so first of all, we're gonna divide it by 2.57 each side. And then we're gonna square, over here is gone, we're gonna square each side. So I have 0.5, 1 minus 0.5 over n is less or equals to 0.03, 2.57 squared. Okay, I multiply by n each side, and then I divide it by this whole thing on both sides. So n is greater or equals to 0.5, 1 minus 0.5 divided by 0.03, 2.57. And I'm gonna put the whole thing in the calculator. Okay, so over here, change it back to 0.5. And the confidence level is 2.57. It's 1834.69. So over here is n will be greater or equals to 1834.69. Okay, and then the integer greater than that will be equal to 1835. That will be your answer. Okay, compared to the first one, we get 1068. We know that the n get bigger when the confidence level get bigger. Okay, so this is the whole procedure of finding the sample size. You just need to use this inequality, plug in everything you know from the question, and solve for it. And the two conclusions we find is over here. If everything remains the same, the guessed proportion gets larger, then your sample size required getting smaller. And also, if your confidence level you are looking for is getting higher, then your sample size is getting larger. Okay. All right, so this is all I have for you for today's video, and you need to know how to find sample size for a given maximum margin of error. Okay, I hope you have a great day, and I do have an assignment on Khan Academy for you to complete. And they shut me off when I'm now stop didn't stop talking yet. That's not polite. All right, and I froze. Okay. So basically, all I want to say to you next is ask you to stay safe, and I want you to take care of yourself and your family. All right, and I will see you next week. The next time I will see you will be next Tuesday. And happy Easter, or wish you have a happy Easter. I talk clearly too much, and I will see you next time. Bye bye.